Hello and welcome to how to solve the 8 plus 11 puzzle. So first of all, let's have a look at what the 8 plus 11 puzzle is and what makes this puzzle so interesting for the internet community. To answer those both questions, just let us have a look at how this puzzle appears in the internet. There it is, a simple set of equations. 1 plus 4 is 5, 2 plus 5 is 12, 3 plus 6 is 21, and 8 plus 11 is the big X, the big unknown. So, before we come to the big groups and the two most seen solutions, let me mention that there is a third group which claims that the correct solution is 19. Why is that? Because I simply say it is a set of equations from which one is correct and two are incorrect. So the last one simply must be correct, then we have restored some kind of balance, right? So we have two wrong equations, two correct equations, the balance is restored. So, okay. I'm coming back later to that point, but now let's focus on the two main groups. One group claims the correct answer to be 96, and the other group claims the answer to be 40. So, who's wrong? Who's right? Well, who knows? Let's have a look at how the two groups come to their solutions. For that purpose, I substituted every digit by a letter, like we do it in algebra. So, just to clarify this, I know that this is mathematically incorrect. It's just for the purpose of demonstration, right? So, let's go. Let's build some formulas out of the letters or out of the equations in letters. Algebraic equations we created, right? So there it is. We have a left column and a right column, or the third and the fourth column. The left column represents the group who gets as a result the 96, and the right column represents the group who gets as a result 40. Right? Let me point out one thing or two things. It may be interesting to know what a direct relationship is and a non-direct relationship. Maybe it's more easy to explain first what a direct relationship is. As you can see, the result of the previous equation is used to solve the next equation. On the left side, without the direct relationship, this is not the case. Every equation is solved by its own. So no previous results are necessary to get or to come to a solution. Right? So let's have a look, reverse engineer it, and now we put the digits into the formulas, which gives us 1 times 4 plus 1 is 5, 2 times 5 plus 2 is 12, 3 times 6 plus 3 is 21, 8 times 11 plus 8 is 96. That's how one group solves the equations. Let me say one thing. I do not need to put any brackets or any parentheses around 1 times 4 or 2 times 5, 3 times 6 or 8 times 11, because please respect the order of operations, which tells me that I have to multiply first and then sum up or subtract, right? So the second group uses a completely different system. How did I do it? They use R1, which is 5 in the first case, puts it in front and sum it up to the rest of the equation. 5 plus 2 plus 5 is 12. And then they use the 12 as a base for the next equation. 12 plus 3 plus 11, 21. Correct. And then they use the 21, put it in front of the fourth equation, and get 21 plus 8 plus 11, which is 40. There we got it. We have two possible solutions, from which one is correct, right? Because an equation with two possible solutions, well, I don't think that this is mathematically correct. Be careful. Of course, I know there are equations with two results, but they have nothing to do with these kind of equations what we are messing around with. So nothing to do with these kind of equations, right? So if we have a problem to solve something very difficult in mathematics, we just solve it with something very easy, which is similar to the problem we have in a difficult situation. And this is one of those examples. I take a set of equations from which I know the result exactly. Everyone knows that 5 plus 5 equals 10, right? Nevertheless, I want to do the same steps with this equation again. Substitute the digits by letters, and then let us create some formulas. Please note again, I have one solution with no direct relationship and another one with a direct relationship, right? So let's see what we get if we reverse engineer it. There it is. 1 plus 1 times 1, and this time I have to put the brackets, right? Because I want to sum up first and then multiply. Is 2. 2 plus 2 times 1 is 4, 3 plus 3 times 1 is 6, and 5 plus 5 times 1 is 10. Right. On the right side, 1 plus 1 is 2, which is correct. 2 plus 2 is 2, plus the previous result 2 is 4. Correct. 3 plus 3 is the previous result 4, plus 2 is 6, which is correct. And then we have 5 plus 5 is the previous result, which is 6, plus 2 is 8. Yeah, you feel it, there is something going extremely wrong destination, right? How does it come? So, as a resume, we can say that we claim 40 to be correct and 80 to be incorrect. But didn't we do the same with both sets of equations? Yes, we did. So, what actually went wrong? Let's have a look at what is really happening behind the scenes. See, if you go from the first equation to the second one, you see that there is a difference of plus 1 between the digits in the first equation and the digits in the second equation. Same situation between 2 and 3. There is a plus 1. But between 3 and 5, there is a plus 2. So this seems to be a pattern change on the left side of the equation. And to solve equations, there are laws. The simplest law is whatever you do on the left side, do accordingly on the right side, or you will get a wrong result. And that is what's happening here. If I have a pattern change on the left side, and I do not adapt the pattern change on the right side accordingly, then I will get a wrong result. Have a look. We take the same formula as before, 1 plus 1 is 2. This is, without any doubt, this is correct. Then we put the 2, or we take the 2 as base to solve the next equation, which is r1 plus 2. This is 2 plus 2, which is 4. This is correct. Now we take the previous result, 4, add 2, and we get to 6. And now, if we take the previous result and use it as a base for the next equation, then you will see that we get 8, which is very logical, but because I didn't care about the pattern change on the left side. Therefore, I get a wrong result. Let's compare it to our root set of equations. So, the original 8 plus 11 puzzle. Well, you already feel it? Yeah, same situation. We have a pattern which starts with plus 1, and then we have the pattern change. But on the right side, we use the same pattern. So, to make it a little bit clearer for those people who are not that good in mathematics, I just transformed the equations a little bit according to the law of equations. What does that mean? Well, I simply subtracted from the left-hand side r1, and the left r1 and the right r1 will eliminate each other so that c plus d is the rest. And on the right side, I have to subtract r1 accordingly. I will do this with every equation I have. The result will be this. That will be the formula we will use to make it absolutely clear what is happening during the pattern change. So, let's have a look. We have 1 plus 4 is 5, and this is a fact. We take this as a fact. Then c plus d, which represents 2 plus 5 on the left side, is 7. And on the right side, we have to subtract r1 from r2. 5 or 12 minus 5, which is also 7. Therefore, 12 can be considered as correct. 3 plus 6 is 21. E plus F must be result 3 minus result 2. Well, 3 plus 6 is 9, and 21 minus 12 is 9 too. Therefore, 21 can be considered as correct. And then the pattern change happens. But exactly the same error as I did before. I use the result of the previous, so the 21, as base for the next equation, which gives us 40. But we know from our simple example, if we do exactly this, we will get a wrong result. Therefore, 40 can be excluded as a valid result of this set of equations. But how to solve this culprit? Well, as we can see, from 1 to 2 is plus 1, from 2 to 3 is plus 1, and from 3 to 5 is plus 2. In this case, it's very simple. We just squeeze in the 4 plus 4 between the third and the fourth equation, and we restore the logic pattern to plus 1. And now let's see what happens with our new set of equations. Well, there it is. 1 plus 1 is 2, 2, and 4, 6, and then we got 2 that we have to solve, right? And we take, once again, we take our patterns we used before, our formulas we used before, and now do the reverse engineering, and there we go. 1 plus 1 times 1 is 2, is 4, is 6, is 8, is 10. So the result without direct connection is still the same. It is 10. But the big difference is the right side, which gives us 10 as a result too. Match. This is an indicator for the fact that we have a correct solution, right? So let's compare it directly to our root puzzle. If we use every previous result as a base for the solution of the next result, we know that we will get a wrong solution. So what can help us out here? Doing the same as with the simple equation. Just squeeze in a couple of equations and restore the pattern to +1. Simple as that. We can fill in our first solutions, which is 5, 12, and 21. And now we have to solve the next equations. 4 plus 7, 5 plus 8, 6 plus 9, 7 plus 10, and then we come to 8 plus 11. But before we do this, I could put the 21 in front of the 4 plus 7 and just count them together. I will come to 32. But I want to point out something. I want to take your interest to a very interesting point. Look at this. The upper 5 and the lower 5 and the 1, they have a relationship. Because if I divide the upper 5 by the lower 5, the result is 1, the upper 1. And take a look at the 12. If I take the 12 and divide it by the 6 in the next line, it is the 2 on the first line. This is a logic pattern. In colors, the yellow block of the line divided by the brown block of the next line is the blue block on the line. So 5, top 5 divided by the brown 5 is as a result 1, the blue block. 12, the yellow 1 divided by the brown 1 on the next line, 6, gives me as a result 2. And now 21 divided by, and now let's consider our root equation. If I would divide 21 by 11, well, we should get 3, right? Following the logic pattern, we should get 3. Is this correct? No, not at all. But 21 divided by 7, this is 3. As a matter of fact, it is. And if we follow that pattern, we can easily say that the next result must be 32, 45, 60, and 77. And we can therefore assume that the next step in the pattern would be 9 plus 12. And now is the question, what number do I have to divide by 12 to get 8? Sure enough, it's 96. Well, let's see what we've got. This is our equation as we have it now. Now let's solve it according both methods that we have already seen before. The direct relationship and the no direct relationship. The direct relationship, we put every previous result in front of the next equation and just count everything together. 5, we have 2 plus 5. Plus 5 is 12. Then we take the 12 as a basis for the solution of the next equation. 3 plus 6 plus 12 is 21. 7 plus 4 plus 21 is 32, 5 plus 8, and so on and so forth. And we get a result of 96. And concerning the no direct relationship, well, the result is 96. So, what is the conclusion about it? We could assume that 96 is a valid solution for this puzzle. But there is a big but, a very big one. Let's have a look at the root puzzle. And there is something very special. It's something that we mentioned before. We have two incorrect, absolutely incorrect terms in it, or equations in it. They are absolutely incorrect. So, do you really think that counting or determining something or determining a solution by using wrong results as a base gives us a correct result? No, definitely not. Therefore, we can exclude 40, and we also can exclude 96 as a result, because the base is already wrong. And if the base is wrong, then what in heaven's name is the result then? Wrong. Okay, I commit there are some special situations in which we use wrong information and got a correct result, but that's an absolute exception, right? But what could we do? Because let's be honest, the problem is that we say that 2 plus 5 equals 12, and 3 plus 6 equals 21. This is incorrect, but we have another possibility. What if we could say that 1 plus 4 corresponds to 5, and 2 plus 5 corresponds to 12? That's an enormous difference. So what we could do is simply change the equal sign to the corresponding to sign. And then, but only then, 96 would be a correct solution. But I'm pretty sure, I have been pretty sure before, and I'm still pretty sure, that the creator of this puzzle would not accept in any way this solution. Why? Now, what is 149? Well, when I teach some IT stuff, especially network and IP addresses, the students must know where the numbers and digits come from and which number systems to use. And the number system we are working with is the decimal system. We know it as a decimal system. 149 is a decimal digit. But we also call it a base 10 digit. Why is that? First of all, because we have 10 digits to form numbers with. But more important is that we have a system of powers which has as a base number 10. Well, what does that mean? Take a look. That are our powers. 10 to the power of 0, 10 to the power of 1, 10 to the power of 2. And the digits in our 149 tells us how often I use the 10 to the power of 2, or how often I use the 10 to the power of 1, or how often I use the 10 to the power of 0. From which we know, by the way, that is 1, 10 to the power of 1 is 10, and 10 to the power of 2 is 100, and so on. 10 to the power of 3 is 1000, and so on, and so on. And we take these powers as often as we need them. 1 times 10 to the power of 2, which is 100. 4 times 10 to the power of 1, which is 10, which is 40. And 9 times 10 to the power of 0, which is 9. And this gives us the digit 149. Alright? So, similar to that, we have a set of number systems, from which one of the most famous is the binary system. We have an analogy, because it works with the same method or along the same principles. Principles? I don't know. The same methods. However, you have to excuse my English. It's rather a long time ago that I used it, and it suffered a lot during the years. But however, I hope you understand, and let's go on. So, a student then asked me if we have other number systems where we can count with. I said, of course, we have a lot of them. For example, base 64. We have base 16, which is better known as the hexadecimal. And we have a base 6, a base 8, whatever. And during my break of this day, I came again along our famous puzzle. And I had a very strange idea. So I didn't know if it has any base of existing, this idea, but nevertheless, I started to convert every single result, so the results that I know, 5, 12, and 21, into base numbers. And something very weird fell into my eyes. Look at that. Well, 2 plus 5 is 7, but in base 5 it is 12. And 3 plus 6 is 9 in base 10, but is 21 in base 4. Whoa, that's interesting, isn't it? So, let's have a look at the top equation. What if 5 is simply 5 in base 6? Is it? Yeah, it is. For sure, yes. Now you should see the logic behind that, what the creator of the puzzle did. The logic is not something that has to do with direct connection or non-direct connection. No, the logic lays in the descending base numbers of the results. Really look at that. And then I thought, that is the solution of it. That is the solution to that puzzle. Because we are not looking for a 96, or a 40, but we are looking for a 19, from which I already told that it is the correct answer, but along the logic of the descending base numbers, we are looking for a base number 3, which is base 10, 19. Well, let's go. 19 base 10, converted to base 3, and that is what we got. We have 2, 0, 1. And that is the only solution for that puzzle, because I'm quite sure that that was the intention of the creator of that puzzle. Alright, so that's it. Just keep in mind that 5 is not 5 decimal in decimal or 5 in base 10, but it's 5 in base 6, and the 12 is in base 5, the 21 in base 4, and the 201 is in base 3. And then every single equation is 100% correct. Funny, isn't it? Okay, thanks for viewing. I hope you enjoyed. Please leave me a comment or hints or tips, and see you next time.